Hey everybody, welcome back. So today we're going to be talking about piecewise defined functions. Now the best way I can describe piecewise defined functions is they're really the Frankenstein's monster of functions, because piecewise defined functions take literal pieces of functions that we already know and sort of glue them together into one monster function. So an example of this is given below. So let's let f of x be. Okay, now let's kind of go over what this all means. So notice we have a set bracket. This is telling us what our pieces are. The functions to the right of the set bracket, these are the functions we're going to be taking pieces of or from, and then the inequalities on the very right are telling us what piece we're taking. So this piecewise function is taking x cubed plus 1, but it's only taking x cubed plus 1 when x is less than 1. Then it's 2x when x is between minus 1 and 5. And then once x is bigger than 5, the function becomes square root of x. Okay? So today we're going to go into how do you evaluate these types of functions and how do you graph these types of functions. So let's start with the evaluating piece. Okay, so let's say, and we're going to keep this example f of x here, let's say we wanted to evaluate f of 4. Okay. Do some erasing really quick. All right. So when you're dealing with a piecewise function, whenever you take your input, you need to look at your inequalities. So we're plugging 4 in. So we have to figure out which inequality does 4 fit in. So is 4 less than negative 1? No. Is 4 in between minus 1 and 5? Yes. So that means that f of 4 is going to be 2 times 4. We're plugging it into 2x in this case because 4 is between minus 1 and 5. So this is equal to 8 in this case. Okay. A lot of students, when they approach piecewise functions, whenever they're plugging something in, they think that they have to plug it into each one of these functions, but that's just not the case because that wouldn't give us a function in the end. Whenever you're plugging something in, check your inequalities here. Which inequality does that number fit in? And then you plug it into that function. Let's try f of 16. So again, we're going to do the same thing. We're plugging 16 into this function now. So which inequality does 16 fit in? So is 16 less than minus 1? No. Is 16 less than minus 1? I'm sorry, is it greater than minus 1 and less than minus 5? Or less than 5? No. Is it greater than 5? For sure. Okay, so we're plugging 16 into this piece right here, square root. Okay. So we get the square root of 16, which is 4. And look at me forgetting to box my answers. And then lastly here, f of minus 2. Okay, we're plugging minus 2 in. So again, we're going to check which inequality does minus 2 fit into. And notice minus 2 is less than 1. So we're plugging it into x cubed plus 1 in this case. So this is equal to minus 2 cubed plus 1, which is minus 8 plus 1, which is minus 7. So again, when you're plugging numbers into your piecewise functions, take your input, figure out which inequality it matches or it fits into, and then evaluate at that function. Don't evaluate at all functions. Okay. Moving on, let's talk about how to graph a piecewise functions. Now, there's a bunch of different approaches. I'm going to show you my approach. And again, there might be more efficient ways, but this way will always work. Okay, so whenever I'm given a piecewise function, the first thing I do is I draw a real number line to sort of orient myself. Okay, so we have the function f of x in this case, so it's x minus 1 when x is less than or equal to minus 2. So what I'm going to do here is I'm going to put here minus 2. And notice that we have a less than or equal to. Here is our inequality. So that means that this function, when x is minus 2, it is x minus 1 in this case. So I'm going to put a filled in hole here. Okay. And then I'm just going to write above, or I'm going to shade this in, and then I'm going to write above this part of the real line x minus 1, because this is telling me that when x is less than minus 2 or equal to it, we're the function x minus 1. Okay. And then I'm going to proceed. I'm going to change colors so we can color coordinate a bit. All right, so when x is between minus 2 and 4, and notice here it's a strict inequality. Well, let me erase that so we can see what we're looking at. When x is between minus 2 and 4, the function is just 3. Okay, so I'm going to denote that as, so here's minus 2. Let's go ahead and put down 4. So when x is between minus 2 and 4, which is all this stuff right here, our function is really just 3. Okay. Now notice, since we have a strict inequality, notice what I did. I didn't put a filled in hole like I did over here for the first piece. I put empty holes here. So be careful about that. When you have strict inequalities, that means you're going to have holes. If you have equalities in your inequalities like this, okay, then you're going to have filled in holes. And then lastly, what happens when x is greater than or equal to 4? I'll go back to blue. So all of this, our function here in this case is x minus 2 squared. Okay. So again, this picture, it's not completely necessary, but it just gives me an idea of what my function should be doing on each interval. So when x is over here, it's the function x minus 1. When x is in between minus 2 and 4, it's 3. And when x is greater than or equal to 4, it's x minus 2 squared. Okay, so let's get to the graphing part. Now, what I usually do at this point is I'm going to plug in all the endpoints into the functions, and I'm going to place them on our graph. Okay, now what I mean by that is I'm going to plug minus 2 into x minus 1. I'm going to plug minus 2 and 4 into 3. And I'm going to plug 4 into x minus 2 squared. Let me clean this up a little bit. And I'm just going to plot those points. And I'm going to try to color coordinate as best as we can. Now remember, we're sketching here. This isn't going to be perfect. Okay, so I'm going to first start by plugging minus 2 into x minus 1. So if we plug minus 2 into x minus 1, we're going to get minus 3. So I really have the point, here's minus 1, here's minus 2, minus 1, minus 2, minus 3. I really have this point here. Okay, negative 2, negative 3. Now notice I put a filled in hole there because, again, we have a less than or equal to minus 2. Okay, now we're going to plug minus 2 and 4 into the function 3, which is really, really nice because what do we get? We just get 3 back. So at minus 2, 3, so let's put 1, 2, 3. We're going to get this point, and notice I'm putting a hole there because we have strict inequalities here. Okay, and then we're also going to have 4, 3 as well. 2, 3, 4. Okay. And then lastly, I'm going to plug 4 into the function x minus 2 squared. Okay, and if you plug 4 into that function, you will get 4. So we're going to get this point here. And notice again, I'm going to be putting a filled in hole there because, again, we have a greater than or equal to in our function. Okay, so I've dealt with my endpoints. I've put the right either hole or filled in hole. And now this is, again, a part that might differ from what you're used to. What I usually do is I graph the entire function and then I chop off what I don't need. Okay, so I'm going to graph all 3 of these functions here, x minus 1, 3, and x minus 2 squared. All right, so now I'm going to use different colors here. So for x minus 1, I'm going to use orange. So x minus 1, which we already have a point here, x minus 1 is just the line that has a y-intercept at minus 1. So I know my function will look something like, let's pretend like this is a perfect line. Okay. So there's my line x minus 1. Now, do we want the whole function x minus 1? No. What do we want what piece of x minus 1 do we want? We want x minus 1 when x is less than or equal to 2. Okay, so if I go back down to my graph, I'm just going to erase everything that's not less than or equal to minus 2, which is all of this right here. Okay, so that's my piece right there for x minus 1. Okay. Let's use a different color. Let's use purple. So for the function 3, now 3 is just a horizontal line that looks like this. That goes right through 3, and let's pretend like it's going through 3 at the y-axis there. But again, do we want this whole function? No, remember we're just taking a piece of it, right? We're only taking 3 when x is between minus 2 and 4. So I'm going to erase everything outside of that. So we don't need, actually here, let me mark here on our x-axis. Here's minus 2 and here's 4. I'm going to erase everything to the right of 4 and everything to the left of minus 2. Okay. And then lastly, and we'll do this in green, our function x minus 2 squared. So hopefully you guys remember your transformations. This is the transformation of the function x squared. But since we have that minus 2 next to our input, we're going to the right 2. So this function normally looks like this. Okay. Now again, do we want this whole function? No, and as you guys can see, this would fail the vertical line test. We only want this function when x is greater than or equal to 4. We only want that piece. So I'm going to erase everything that's not greater than or equal to 4. So I'm going back to my function. I'm going to erase all of this, whoops. But I want to keep this part, because that's when x is greater than or equal to 4 here. Okay. And here is our piecewise function here graphed. Okay. And again, it's just like Frankenstein's monster. We're taking pieces of these 3 functions, x minus 1, 3, x minus 2 squared, to generate this crazy looking function here.